know about slabs, this is a few types of slab. So the first type is one-way slab. As you can see here, there are only two beams here. And the second one is two-way slab. As you can see here, there are 1, 2, 3, and 4 beams. And the next one is also a one-way slab. However, it has 3 beams here, which is 1, 2, and 3. And the next one is flat plate. This is called a flat plate because it is flat. The slab is flat. And also, this one is called flat slab. This is because you can see the footing here and the slab is flat. And then the last one is grid or waffle slab. This is because it looks like a waffle and it has many beams here. So, for the first process of slab, excavation is the first one. So, for excavation, we must know the length, the width, and the height of the excavation place. Okay, so let's refer to the original drawing. Okay, from this drawing, I know that the width is 4,500 millimeter, while the length is 4,800 millimeter. Okay, so let's transfer this to the drawing here, and this is it. So the length is 4.8 meter, the width is 4.5 meter, and the height is 0.15 meter. And then we transfer it. So when we transfer, the length must go first, and then the width, and then the height. So the length is 4.8 meter, while the width is 4.5 meter, and the height is 0.15 meter. So I'm going to multiply it by one section. First, I only count for one section, this section. So, and then we will get the answer, which is 3.24 in 3.24 meter cube. The unit is in meter cube. Moving on to the formwork of slab. Okay, so for slab, we don't need no formwork because we only calculate the formwork for beam, which means we don't have to calculate the formwork for slab. Okay, however, I'm going to explain one by one the layer of slab. So the first layer, as you can see here, is the hard core. And then there will be sand blinding, which is the yellow one, as you can see here. And then damp-proof membrane, which is the blue layer here. It's very thin. And then we will put the concrete slab over here. After the concrete slab, we will put insulation, and then we will put vapor control layer, VCL, over here. It is also a very thin layer. And then the last one, we will put the screed on top of it all. Okay, so the next process is reinforcement. So for reinforcement, this is the drawing. However, you cannot see it, so I'm going to zoom in. So this is the original drawing. So for the original drawing, this is the full length, which is 5,100 millimeter. This is the length for this main bar, which is 1,600, and this is the length for this main bar, which is 1,150. So let's see. I am going to divide it into 3 sections, which is first section is this one, second section is this one, and the third section is this one, the long one. Okay, so for the first section, let's see. So this is it. I already draw it. Okay, so we know that the height of this concrete slab is 150. So we want to find the length for this main bar. So we have to minus the concrete cover. So this one 0.15 minus 2 times by 0.025, which is the concrete cover. This one from the top one and from the bottom one. And then we will get 0.1 meter. The vertical length is 0.1 meter. And then we have to plus 0.1 plus 5 times 0.01 plus 1.15, which is from here. And then we will get 1.3 meter. So this 1.3 meter, we change it to kilogram. However, we know that this diameter of this bar, this steel, is 10. So let's see the schedule here. And as you can see here, this is the size of the steel. However, we don't have 10, so I searched already it on the internet. So for 10 millimeter, the weight is 0.617 kilogram per meter. So we have to multiply it by the meter we have just now, which is 1.3. So 1.3, let's count here. 1.3 times by 0.617, and then we will get 0.8 kilogram here. Okay, moving on to the second section. This is the second section. Let me remind you, this is the second section. So for the second section, we know that the horizontal length is 1.6 meter. So we have to plus 5d, which is 5 times 0.01, which is the diameter. And then we will get the answer when we plus this one, and this one is 1.65 meter. And then don't forget that we also have to calculate the vertical length, which is the length, which is 0.15 minus concrete cover, which is 2 times 0.025, and then we will get 0.1 meter. So when we plus the 1.65 meter that we get earlier plus the 0.1 meter that we get from the vertical length, we will get 1.75 meter. I haven't changed this to kilogram yet, so let's change it. Because the diameter is 10, so we are going to use the same one, the same formula, which is 1.75 times by 0.617, and we will get 1.08 kilogram. Let's write it here, 1.08 kilogram. So moving on to the next section of reinforcement, which is the last section. This is it. As you can see here, I already labeled it with 3. So this is the last section. Let's see. Okay, so from this drawing here, we know that the horizontal length is equal to 5,100 millimeter, which is equal to 5.1 meter. And then we have to plus with 5d and 5d here, because there are two curves here, right? So 5d plus 5d, which is 5 times diameter, which is 0.01. So you can see here, plus 5 times 0.01, and then we will get 0.1. So the horizontal length plus the curve will be equal to 5.2 meter. And then we will have to plus the vertical length here, as if you realize, we already count this. This is the same for every vertical length, which is the height is 0.15 minus by the concrete covered, which is 2 times 0.025, and then we will get 0.1. However, we have two vertical length here, so we are going to plus 0.1 plus 0.1. So this 5.2 meter that we have earlier, we will plus with this 0.1 and 0.1, and we will get 5.4. So this is the full length of this bar is this main bar is 5.4 meter, and then we will have to change it to kilogram because the diameter is 10. As I say earlier, we have to times by 0.617. So when 5.4, let's see here, so when 5.4 times by 0.617, we will get 3.33 kilogram. So this is it. So, moving on to the last process, which is concreting. Actually, concreting is the same with excavation. We have to find the volume of the slab that we have to pour the concrete over. So, let's refer to the original drawing again. So, from this drawing, we know that the length is 4,800 millimeter and the width is 4,500 millimeter. Okay, let's transfer them to this drawing, this little drawing here. So the length is 4.8 meter, the width is 4.5 meter, and the height is 0.15 meter. As usual, we have to first write the length and then the width and then the height. So I am going to multiply it by 1 because as the same as the excavation, we only count for one section of slab. So when we multiply everything, we will get 3.24, and the unit is in meter cube because we are calculating the volume of this slab.